So I'll come around and check a little bit more homework in a little while, but I understand we're still kind of getting into the flow of things. So my math lab is new to most, if not all of you. So we'll get this whole system figured out. So here's our look at the calendar. Again, we're starting on page 15 today. So last class we had a snow day, which means that everything in the calendar that I gave you in the syllabus on the first day is wrong. So you're going to use this calendar instead. There should be a copy of this calendar on your table, so grab a new copy, okay? The old syllabus calendar is no more. All right, so today we're going to talk about linear models. Basically, it just means some more word problems where the answers it's going to turn out are lines. That's where the word linear comes from. And I want to talk about another resource that I've just put on your tables, and it's something that's called the 096 practice problems. At the very top it says that, practice problems for math 096. So go ahead and grab a copy of that. Okay, everybody have a copy of the 096 practice problems? Okay, so here's the deal. Heading into each quest and test, and again, those are listed here, like our first quest is now scheduled for February 13th. It's our first full period assessment. So heading into each of those things, I used to have like sample problems for the quests and sample problems for the tests. And they were embedded inside of the packets. And I've decided that I don't want them embedded in the packets anymore. So I took them all out of the packets and I made a separate handout, which is this practice problem document that you just grabbed a copy of, okay? So that practice problem document is a set of all the practice problems for all the tests and quests for the entire semester, all in one place for you. Again, we're talking about this document right here. And so how are you supposed to know which problems are appropriate to study as you're looking for practice heading into quest number 1 or test number 2? So that's where this document again comes into play. And so let's take a look here. See that box right there? It says that quest number 1, the material covered is lessons 1 through 5. And if you want to practice something from lesson number 2, let's see 2 there, you're going to go into the practice problems packet, which you just picked up, and you're going to look at problems 4 and 5. So that right there, that column is the list of all the problems that are relevant to each of the lesson numbers. Does that make sense? I'm hoping it's easy to follow. Again, there's a lot of new stuff in the start of any course, so this will just be something that we'll figure out. But that's what that column is that we haven't talked about yet so far. All right, so a couple of resources in addition to that packet. Number 1, at the end of that packet are answers, just answers, x equals 2, y equals 4, just plain answers, not full-blown solutions. But I do have full-blown solutions. I'm not going to hand them to you, but they are available on Moodle, and it looks like this, just a PDF. Download it, it's in color, it's easy, okay? So there's that on Moodle. And then another thing you'll find on Moodle is a link to a playlist that I made in YouTube where I solved every single one of these problems, full out solutions, and you'll hear me talking and you'll see me writing. And so for example, up in the top of this packet, it tells you exactly how to find anything. So let's see, we're looking right here, last part right before number 1. It says if you want to find something in YouTube, you search for titles like that, 096 practice problem 25, for example. And so I typed into YouTube just a straight title search, 096 practice problem 2, no spaces. And it pulls up the very first hit is exactly what we want. If you look at practice problem number 2 in your packet, it's on the first page, right? You can see that line in the graph. Everybody see it? So that's the video of me going through that problem. Right, and so you can directly find the video for any of those problems in the practice problems list. And also notice that the second hit that YouTube came up with is the playlist that I was talking about. So inside of that playlist are 61 videos, and they are numbered, or they're titled not very creatively, but easy enough to find what you want, okay? So I'm hoping this will all be useful to you. Again, just know there are a lot of resources available. Any questions on any of this? Okay, so last thing, and then we'll jump in again on page 15. I made a mistake on the very last answer to the last problem. So can you take that new packet that you just picked up and flip all the way to the back? And number 56, part B, you're going to cross off whatever's there, and you're going to change it to 3323. For you, 55 and 56 are on this separate page. So change that number to this, and know that that's your page for 55 and 56. Yeah, that's good. For you, it's a separate page, this guy. You'll just throw that in the back of your packet. Everybody find it? Number 56, part B, the very last problem. Change it from 3679 to 3323. We got it over here? Okay. 56B. Okay, so let's get started. I'm going to hand you some more stuff later, but for right now, I'll give you that. Oh, one final thing. There's a yellow bookmark on your table. Grab one of those. This is the schedule for when the Math Studio will be covered by some faculty member. Okay, Math Studio is open many hours more than these ones here, but this is when somebody will be on duty to answer all your questions. Right? So go ahead and grab one of those. Okay, so we are finally back here on page 15, and we need a reader for the daily summary. Jeremy, can you read the summary? Jeremy? Okay, thank you. William, number 1 on page 15. Okay, so let's start here with part A. Again, everything in this problem is going to hinge on somebody making $7.50 an hour. Okay, so we've got a table here, and we're going to fill in the value showing the wages, which we're calling W, that's the blank second column, earned for the number of hours worked, X. So X is the number of hours worked, W is the wages. So if you work 0 hours, how much is your wages? Is $0, nothing. If you work 1 hour, how much are your wages? It was the $7.50. Okay, if we work 4 hours, now we have to do a little calculating. What do we need to do with the $7.50? Multiply by 4. So we'll just put off here on the side 4 times $7.50. And that turns out to be 30 bucks. And then we play the same game in the last 2 rows, right? 6 hours at $7.50 an hour turns out to be 45 bucks. And then 10 hours, that's one of the easy ones, right? That's 75. I'll use some handouts. I don't have any extras with me right now, so sorry, just do the best you can. Okay, so moving on to part B. Could you read part B for us? How much does this person earn for every additional hour? $7.50, yeah? And it's a constant change of $7.50 every hour, right? And so does this rate of change, does this hourly rate change or stay constant? It stays constant. And so we'll get Savannah. Can you read this for each? Okay, thank you. So let's see if we can do part C now. We'll go to Steve. And then some stuff with X's in it. That's my way of informally writing stuff with X's in it. Okay, so W in terms of X means W equals, all right, something with X in it. Remember, X is the number of hours. 750 times X, right? That's exactly what we did in the table, right? We took 750 and we multiplied it by the number of hours every time. So that's our equation. And again, this is a new definition for us. W in terms of X means W equals. You see in terms of, that is a very precisely defined mathematical phrase, and it means equals. W equals something with x's in it, as opposed to x equals something with w's in it. This is W in terms of x. Okay, let's plot a few of the points. This is part D. It says plot the points from your table in part A and then graph the equation from part C. So go ahead and plot all the points in the table and then connect the dots in some reasonable way. Okay, so what did we discover about these points? It looks like they form a line, right? I mean, if you did it right, then you should be able to use your bookmark as a straight edge and connect those dots with a straight line. And I want to just mention this whole constant rate of change business again. So let's see, we saw that 0 and 0 and 1 and 750, and what was the next one? 4 with 30. And then what was next? 6 and 45. And then 1075. So so you've got that, and then you draw your straight line with a straight edge if you can, and something like that. And so let's talk just for a moment about this constant rate of change. Every time we move 1 hour to the right, if we want to get back onto the line, we need to go $7.50 up. And if you are at this point and you move 1 hour to the right, you go up $7.50 to get back on the line. And it doesn't matter where you are on the line, some random point over here, if you move 1 to the right, you move $7.50 up. That is a constant rate of change. Every time you move 1 to the right, you move up by exactly the same amount. But you can distinguish that, for example, from this curve. We'll talk about parabolas much later in the semester. But that's a rough sketch of the graph y equals x squared. And you can see here that maybe you move, let's say you move 1 unit to the right, and then you have to go up by 0.2 or something. And then the next time you move 1 unit to the right, you got to go up by a lot more than 0.2, yes? This is not a linear thing, and it's that constant rate of change that makes something linear. That's basically the definition of linear. Okay, more vocabulary in E. Let's go to Alex. Okay, I'm not saying that's a great mnemonic device. I was kind of tired when I made it up, but independent and dependent, you guys got to tell which one is which. And it is always the case that the letter that is by itself is the dependent variable. It's just definition. But the word dependent and independent sound really similar to each other. We got to make sure we know which one is which. So this is my little cutesy mnemonic device. I don't know if it's helpful, but I hope it is. Johnny Depp starred in Pirates of the Caribbean, and many times in those movies he was by himself on an island, yes? So the letter that is by itself in the equation, let's just like Johnny Depp by himself on an island, is the dependent variable. And then the other one is the independent variable. So let's be clear here. W equals 750x, which is the dependent variable. W or x, dependent. Is W, the one that's by itself like Johnny Depp. So that one is the dependent variable, which means by process of elimination, the x is the independent variable. Yeah? Just vocabulary. It's not hard, but I guess it is until you know exactly what the vocabulary means. Okay, moving on to 2A. Cody? Okay, so I'm asking you to recopy one of those equations. You can just put it right over here, but copy the right one. One of them expresses t in terms of r. So think very carefully about that phrase in terms of, which we defined earlier, and then rewrite one of those equations. So t in terms of, as soon as I see that phrase, what do I know the equation will start with? T. And what will the next symbol be? Equals. I see t in terms of, I don't need to read any farther. I know immediately it begins t equals. So apparently this is 121r. Okay? T in terms of r. All right, more vocabulary here. Since one of those letters, and the one that we just rewrote, is by itself on the island in the equation, we just wrote. Okay, so let's see, which letter is by itself? T. So that means that something is the blank variable. So T is the variable we just talked about. T is by itself, so is T independent or dependent? T is dependent. And then fill in the other two blanks if you would. And some letter is the some kind of variable. What letter goes in the second blank? R, and R is the independent. Okay, I'm not saying these are the most exciting equations, or sorry, the exciting problems to think about, but it's just straight vocabulary, and we have to know the vocabulary. Okay, last thing we're going to do today in the demo part anyway, involves graphing an equation by using intercepts. So we haven't seen this phrase or this word before, but you probably have seen it in some previous math class, the intercepts. So the equation is 3x plus 2y equals 12, and we're going to graph the intercepts. So I'm going to jump, you can read some of this stuff later on. We're just going to jump to the table. And you can see that in this table, we have let x equal 0 in one row, and then in a completely separate row, we have let y equal 0. And these are separate parts of this problem. So if we let x equal 0 in this equation, I'm just going to rewrite it, but I'm going to change that x to a 0. 3 times 0 plus 2 times y equals 12. Everyone see what we did? Copied everything, but just changed that x to a 0. 3 times 0 is 0. So this 0 plus 2y just becomes plus 2y equals 12. And then finally divide by 2 and we get y equals 6. So y equals 6 is the thing that goes right there. When x is 0, y is 6. See it? Now we're going to play the same game, but we're not going to change x to 0. We're in the second row. We're going to change the y to 0. So if we change the y to 0, copying everything, we get 3x plus 2 times 0, and it's still equal to 12. And go ahead and solve that equation for x. So 3x and then 2 times nothing is nothing. So 3x is 12. X turns out to be 4. And that 4 goes right down there. So when y was 0, x turned out to be 4. Okay, and so we're about to plot the intercepts here. But I want to point out one really common and easy mistake that you need to avoid is to think, okay, let's see. We see x equals 4, and we see y equals 6, and that's a point, right? 4 comma 6 right here. Yes? X is 4, y is 6. What's wrong with that? Yeah, those two numbers, the 4 and the 6, have absolutely nothing to do with each other. They came from completely different equations. They don't correspond to a single point. They're two different points. What did we do in this very first row? What was the first thing we established? Was it x was 0? So it doesn't make any sense to think, okay, but then later on x is 4. That's another thought entirely. We start with x equals 0. It's not going to change. So it's not the point 4 comma 6. It's actually the point 0 comma 6. Right? Just reading that first row. X was 0, y was 6. Completely new thought. In the bottom row, what are the coordinates here? 4 comma 0. So it's really easy to kind of fall into that trap because you see an x and a y and you want to put them together and make a point. But it's actually two different points. So we plot those two different points. 0, 6, I guess that's up here. And 4, 0, that's way over there. And then connect with a straight line. Good enough. So that's a very quick way to graph that line, okay? And those 2 points are called intercepts. The definition's below, but I think that you already know what the intercepts are. 4, 0, is that the x-intercept or the y-intercept? That's the x-intercept, the one that's on the x-axis. 0.6 is called the y-intercept. Any questions about graphing a line using the intercepts? Okay, so let's see, there's the answer key. Moving on to the activities on the next page. If there are new people sitting at your table today, introduce yourself and then work through all of the activities.